Method using for agriculture by sedimentation method. The sedimentation method in water purification for agriculture involves allowing suspended solid particle in water such as soil, organic debris and other impurities to settle down at the bottom of a container or tank by gravity. This process reduces the turbidity and particle load in the water, making it cleaner for agriculture use. How sedimentation works. Water containing suspended particles is collected in a settling tank or reservoir where it is left undisturbed from a certain period. Heavier particles naturally settle to the bottom due to gravity, forming sediment or sludge. The clearer water above the sediment can then be drawn off carefully, often through a process called decantation. The settled sludge is periodically removed from the bottom. Role in agriculture. Sedimentation removes large organic materials like leaves, soil, and gravel from surface water sources before irrigation. It decreases the amount of suspended solids which can clog irrigation systems and harm plants. Improve water quality for crops, protecting soil and reducing the risk of contamination. It is a low-cost, simple pre-treatment that requires minimal materials and skill, hence suitable for agriculture settings. Enhancement of sedimentation. Sometimes coagulants like alum or natural coagulants, example seeds from moringa trees, are added to aggregate fine particles into large flocks that settle faster. Sedimentation tanks can include inclined plates or tubes to increase surface area and improve settling rates. Summary. Sedimentation in agriculture water purification is a gravity-based physical process that makes water suitable for irrigation by removing suspended solids. It is often the first step before additional treatments like filtration or disinfection if needed. The method is simple, economical, and effective for treating water used in farming. This explanation covers the sediment water purification method used in agriculture, including its process, benefits, and enhancements. Advantages and limits of sedimentation agriculture irrigation. Sedimentation in agriculture irrigation is widely used to reduce suspended solids and improve water quality, but it presents both notable advantages and important limitations. Advantages of sedimentation. Sedimentation effectively removes heavier suspended particles from irrigation water, reducing clogging in irrigation canals, pipelines, and sprinklers, and thus improving overall irrigation system efficiency. The process is generally low cost compared to more advanced filtration or chemical treatment options, making it accessible for small and large farms. Implementing sedimentation can reduce the frequency and cost of mechanical desilting operation needed in irrigation canals, resulting in savings for maintenance budgets. Improved particle removal helps maintain water distribution capacity and supports higher reliability for downstream farmers, which raises farm income and crop yields. Sedimentation can help retain nutrition-rich particles, offering the potential for sustainable soil management and nutrition recycling on farmlands. Limitations of sedimentation. Sedimentation is not effective for removing fine clay, slit, dissolved chemicals, and pathogens, so additional treatment may be necessary for higher water quality standards. Regular maintenance is required to remove accumulated sediments from traps or basins, which can be labor intensive and may incur ongoing costs, especially in areas with high sediment inflows. In irrigation system exposed to excessive sedimentation, channels and reservoirs can rapidly fill, decreasing water storage and distribution capacity, which compromise long-term operation if maintenance cannot keep up. Environment concerns may arise from mismanaged sedimentation or frequent dredging, as well as secondary issues like waterlogging or salinity if drainage is inadequate. Sedimentation practices must be carefully designed. Undersized or poorly located basins are often effective at protecting irrigation infrastructure and may require redesign and additional investment. Sedimentation offers reliable physical removal of larger solids, but to achieve safe and sustainable irrigation, it is best paired with other water purification or management practices, especially when fine contaminants or dissolved pollutions are present. Thank you for all and who gave this opportunity to give this top